Hi everyone, welcome back again. So in this video, we are going to solve the problem of weekly contest 498. And this one is the fourth and hard problem of this contest, right? So last three video, you can check out my previous video. Now let's go with this problem. First, we'll see the brute force approach, then how we can optimize it, right? Now let's understand the question. They are saying we have given two integers, L and R, and then we have given the direction string. In that direction, what they have given? They have given D means we need to go down, R means we need to go right side. For each integer x in range L to R, okay, x is any number between L or R. If x has fewer than 16 digits, right, we need to make it 16. It means that we need to put leading zeros. Okay, if we have any number, for example 100, so we need to put 12 0 before 100, so it will become the 16 digit, right? Now what they are saying, we have given 4 cross 4 grid, and in 4 cross 4 grid we need to put that number, right, or that digits, that 16 digits. Now we need to traverse. How we need to traverse from 0 0 means top left to bottom right corner, and every direction size is only 6, because to reach this position, how many direction we need? Down, 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 3, right, 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 6. Now what we need to find? We need to find the good recorded sequence. And how we can decide this is good recorded sequence or not? It means that whatever number we are traversing, that number should be in non-decreasing order. Non-decreasing means if any digit came, so after that we can put the same digit or greater than that digit. Okay, for example, if we have given 1, after that we can take 1, 2, 3 like that. But after 1 we can't take 0. Okay. Now let's understand with this example. We have given 8 and 10. In the 8th case, we have only one digit. We are putting all zeros before that one. Now it is the good sequence or not? We need to traverse. We need to traverse D, 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 down, 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 then right, right, right. This is non-decreasing. You can see this is non-decreasing. It will give you count 1. Again for 9, it will also give you good count as a 1. But for 10, after 1, 0 is coming. That's why this is not good sequence. Right? How we are putting the digits? We are putting like this one: 0, 0, 0, then 0, 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Likewise. Right? And we need to traverse from this one 0, 0 on the basis of direction. They are saying from here go down, then go down. 2 is coming now. Again we need to go right 3. Again we need to go right 4. Then need to go down 8 and then 9. 0, 0, 2, 3, 4, 8, 9. 0, 0, 2, 3, 4, 8, 9. Now you can see this is non-decreasing. So this will contribute in your answer. Same for this one. And from where to where we need to check? From L to R we need to check. And you know that this is the 16 digit. If you will go one by one, you will take number like first you will take L, then L plus 1, L plus 2. This will give you time complexity 10 to the power 16. If time complexity is 10 to the power 16, it will definitely give you TLE. Now what we can use? We can use here digit DP. And how we can use digit DP? Let's see. Now try to understand. We have given this grid, okay, and we have given L and R. right? We have given in number, for example, they have given 8 and here they have given 15. From 8 to 15, how many numbers sequence is the good sequence, right? So good sequence means, okay, from here to here, we need to reach and in that path. And they have also given the path like D, 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 R, R, R. So this is the path, okay. And in this path, we need to check how many, like, whatever sequence we are getting. In this path, we need to check whatever sequence we are getting, that sequence should be non-decreasing. Non-decreasing means 1, 1, 2, 2, 3, 4, 5, like that. After 1, 0 should not be there. If this condition will come, we will return from there only. Okay, we don't need to go forward. Okay, so how many index we have? We have index 16 index, 4 cross 4 grid. Okay, we will convert this into the single array. Okay, and you know that for the digit DP, every index is either tight or not tight. Tight means if we have given number 1, 2, 3, if current number is 1, this index is tight. It means that this number can vary from 0 to 2. Okay, if 1, 2 is given, this number can vary from 0 to 3. Okay, after that, whatever number will come, this will be greater than 123 only. Now again, if one is tight, this one is tight and this one is not tight, you can vary here from 0 to 9. Why you can vary? 1, 1, 0, 1, 1, 1 till 1, 1, 9. This can vary till 9. But if 1, 2 is there, this both are tight, you can't vary this one. 0, 1, 2, 3. If you will come as a 4, if this will write as a 4, this will be greater than our this number 123. That's why we will not go beyond the R, right? So how we can do? So we need to track the tight also, tight index. Now again, how many digits we have? 0 to 9. Okay, every index we have only one digit. We need to track the previous digit, right? If previous digit is less than or equal to current digit, then we can go to the next index. Otherwise, we will return from there only. Okay, and we will use for these three. We will use DP for these three index. Okay, now let's see the code how we have done this. Now let's try to understand the code. We have given L, R, and directions. Now we have converted this 4 cross 4 grid into the single array and started index is 0 row and 0th column and is path 0 is true. Okay. Now in direction we will traverse from 0 to from 0 0 where we are going. We are going, if they are saying D, it means we are increasing the row number. If they are saying R, it means we are increasing the column number. And finally, we are computing the current index, their current index, and we are putting their true. And we are computing valid until R and from this path, whatever path we are getting. And we need to decrease till L minus 1 from the same path. It means that if we have given L to R, okay, there is 0. L to R, we will compute from 0 to R, then we will reduce from 0 to L minus 1. So we will have L to R. Okay, 5 to 9 0 to 9, this will give you 9, and 0 to 4, this will give you 4, it will give you 5, 5, 6, 7, 8, 9. Okay, I got it. That's why we have, first we are computing till right, and then we are computing till L minus 1, and then we are reducing it. Now, if our limit is less than 0, then we are returning the 0. Otherwise, we are converting this limit into the 16-digit string. Okay, this is saying append 0 if they are not till 16 digit. Okay, overall we need to make the string 16-digit string. Now we are using memoization, 16 for the index, 2 for the types, and 10 for the our 0 to 9 digits. And initially we are filling with -1. Now we are iterating through. This is the index, this is the current index, is type index only, and this one 0 is the our whatever last value is there. Got it? And this string we are sending, and path we are sending, and then this is the memoization. If index is 16, we are returning 1. It means that till now we are getting non-decreasing. Okay, if we are able to find the memoization is not equal to -1, then we are returning memoization element. Now here we are checking if our typed digit, previous digit is typed, then we need to go from 0 to the current digit. Here we have seen 0 to 3. Otherwise we need to go till 9 for this one. Initially we are taking total value is 0. Now we are going through digit 0 to whatever maximum digit we are getting, right? And we are checking if our previous digit is typed and current digit is maximum digit, means if this one is typed and this current digit is also reached to the maximum value, so it means that this is the type now. So we will put that as a 1. Okay, if this condition will not be satisfied, then current digit is not typed. Okay, now we are checking this index is reachable. If this index is reachable, then we are checking our current digit. If current digit, whatever digit we want to put at that index, is less than our previous index value, last value. That's why I told you previous value. Initially we have taken 0. Next time many number will come. Then we are sending this one is the previous digit. Same for the this one. And we are going to the next index. Okay. If this condition is not true, we are going to the next index. It means that current index is not reachable. Then we will go to the next index and we will send the same for the type and last value. Okay, because we are not performing any operation. If we are not able to reach any index, we are not performing any operation, and these parameters are same. And finally, we are storing total valid count into the DP memoization. Right? If you are not able to understand, please try to go through once again. Okay, thanks for watching. See you in the next video.